Hello, so we are given a function f of x, which is a quartic function, right? How do we know that? Well, the highest power of x is to the power of 4, and all the other terms are polynomial terms, right, with x's or constants. And we are asked to find the gradient of this graph at the point where x equals 2. So, asking for the gradient, so we should be thinking, alright, half of calculus is to look at the gradient, right, to differentiate. So our first step is to find the first derivative of f of x, which we denote as f prime of x. And so the derivative of x to the power of 4 is we take the power, 4, and multiply it out the front, giving us 4 times x to the power of 4, but instead of to the power of 4, we subtract 1 off of the power, which would leave us 4 minus 1 gives 3. So the derivative of x to the power of 4 is 4 times x to the power of 3. Similarly, with 3x squared, we take the power of 2, multiply it by the coefficient, so 2 times 3 gives positive 6, and then we subtract 1 from the power. So 2 minus 1 gives 1, which we don't need to write, because that is implied when we don't have a power there. And lastly, the derivative of negative 17. So the best way to remember this is that the gradient of a constant is 0. In other words, if we had our xy graph and we plotted negative 17, y equals negative 17, it would be a flat line. In other words, the rise is 0 over the run. So the gradient is 0. In other words, the derivative of a constant is 0. It also does work with the rule, which I'll just show you, because we can put x to the power of 0 attached to the negative 17, because x to the power of 0 is 1, so I didn't change anything. Now using the same rule, 0 multiplied by negative 17 gives 0. Right, so the rule still does work. Alright, and plus 0, we don't need to write that. So we found the derivative. Pat on the back to us. Now, we haven't answered the question. It's asking us to find the gradient. What we've just found is called the gradient function. What that means is if we give it a value for x, it will tell us the gradient. And now let's reread the question. We're looking for the gradient, and we're given x. So we can substitute an x into the gradient function to get the gradient at that x value. So to denote that, when we have this f like prime bracket, in for x goes 2, and what that means is we substitute 2 in for x. Then we evaluate it, so 2 cubed is 8, 8 times 4 is 32, plus 6 times 2, that's 12, to give us, what's that, 44? And so what that tells us is the gradient of f of x when x equals 2 is 44. Awesome, and that is achieved. I will show you how you can check on your calculator. This will not get you the marks, however, it's good to know how to use your calculator to check. So we go menu graph. Now in an exam your calculator is reset, so you do need to turn this setting on. So it's shift menu to go to setup, and you see the word derivative. We want to turn that on, so F1. So we can exit. Now we graph our original function, so the quartic, so x to the power of 4 plus 3x squared minus 17. Right, that's our original function. We can hit draw. So my window's a bit zoomed in. So we can hit window, zoom out, execute. That looks a bit better. Now, the question asks us for the gradient when x equals 2. So we can hit the trace button, F1, which lets us trace the graph, and we give it an x value, and it gives us the y value, but we turned on the derivative, so it also gives us the derivative. So if I type 2, execute, when x is 2, the y value is 11, and the gradient is 44, which is what we got. So that's reassuring. So that's one way you can quickly check on your calculator.